Hello students, today we are going to continue the topic infinite series, that is unit 2 of your third SEM syllabus. In the last class we have gone through the basic things of an infinite series, okay, and also we have proved a theorem that is the necessary condition for convergence of an infinite series. What is the necessary condition for the convergence of an infinite series? Okay, this is what you have studied in the last class. If sigma un is convergent, then limit un is 0. This is what you have studied. If sigma un is convergent, then limit un is 0. What about the converse? Okay. Whether converse is true? No. That is, whenever limit un is 0, the infinite series sigma un need not be convergent. Which example you have given? You have given the example of sigma 1 by n. Sigma 1 by n. For sigma 1 by n, the limit of nth term is 0. But sigma 1 by n is not convergent. Reason ಏನು ಕೊಟ್ಟಿದ್ರಿ? Sigma 1 by n is not convergent. You have supplied the reason here by quoting the p series. Sigma 1 by n power p. This is convergent for p greater than 1 and divergent for p less than or equal to 1. In your sigma 1 by n series, power value is 1, p value is 1. When p is equal to 1, the series is divergent. Okay, so whenever sigma un is convergent, limit un is 0. But it is not true. The converse is not true. If limit un not equal to 0, as n is tend to infinity, sigma un need not be convergent. Sigma un is divergent. So, this theorem, yesterday whatever you have proved, it is used for testing for divergence. You calculate limit un as n is approaching infinity. If limit value is not equal to 0, then it is the nth term test. Sigma un is divergent. So we are using the theorem not for convergence. Statement length out. If sigma un is convergent, then limit un is 0. Convergence implies this. Suppose limit un is not equal to 0, then the series is not convergent, it is divergent. So we are using this as a test for divergence. Okay. So you have already taken, I think this example is sent to you. 1 by 2 plus 2 by 3 plus 3 by 4 up to infinity is not convergent. This is what you have to prove. What is the nth term here? Un. It is 1, 2, 3, etc. n ಬರುತ್ತೆ. ಇಲ್ಲಿ 2 ಅಂದರೆ 1 more than 1. It is n plus 1. See, when n equal to 1, 1 by 2 ಆಯಿತು. n equal to 2, 2 by 3. 3 ಇದ್ರೆ 3 by 4 etc. ಇದು un ಆಯಿತು. Calculate limit un. Divide the numerator and denominator by n. You get this much. When n is approaching infinity, 1 by n is tending to 0. So limit value is 1. So limit of nth term is not equal to 0. Therefore the given series is not convergent. Fine. You may say that it is divergent, but it is not convergent. Okay. You are showing that given series is not convergent by using the nth term test. Limit of un is not equal to 0 and hence series is not convergent. Okay, fine. Next, Cauchy's general principle of convergence for series. It is similar to the one you have proved for sequences. Right? What is the necessary and sufficient condition for sigma un to be convergent? This implies and implied by For a given epsilon greater than 0, there exists a positive integer m such that modulus un plus 1, un plus 2 plus etc. un plus p, un plus p, right? This is less than epsilon for all n greater than or equal to m and p greater than or equal to 1. Okay? You are proving Cauchy's general principle of convergence for a series. A series is convergent if and only if modulus un plus 1, un plus 2 up to un plus p is less than epsilon for a given epsilon greater than 0 for all n greater than or equal to m and p greater than or equal to 1. 1. Okay, fine. Again, how to prove this? Assume that sigma un is convergent. Sigma un is convergent. When do you say that infinite series is convergent? If the sequence of partial sum is convergent. Sequence of partial sum is convergent. Okay. Apply Cauchy's general principle of convergence. Apply Cauchy's general principle of convergence for the sequences. Sequences can you prove madiri. What is it? Mod Sn plus p minus Sn is less than epsilon for all n greater than or equal to m and p greater than or equal to 1. This is Cauchy's general principle of convergence for the sequences. I repeat. Assume that sigma un is convergent. The infinite series is convergent. By saying that an infinite series is convergent, you mean that its sequence of partial sum is convergent. Okay. If sequence of partial sum is convergent, by Cauchy's general principle of convergence for sequences, mod Sn plus p minus Sn less than epsilon for all n greater than or equal to m and p greater than or equal to 1. This is if and only if. Right? If and only if barutte idakke. What is Sn plus p anta nodi? Sn plus p andre it is u1, u2, u3, un, un agi un plus 1, un plus 2, un plus 3, right? Up to where? Up to un plus p. Illi tanaka hogbeku. Fine? Illi Sn. Sn andre anta sum of n terms. u1, u2, u3, un. Fine? What is the difference between the two? Idu cancel, illi tanaka cancel. Istulit. The difference between the two is modulus un plus 1, un plus 2 up to un plus p, which is less than epsilon for all n greater than or equal to m. For all, the notation is greater than or equal to m and p greater than or equal to 1. This is nothing but the Cauchy's general principle of convergence for a series. The series is. So proof is completed with this. Hence the proof. So in order to prove the Cauchy's general principle of convergence for a series, you are making use of the Cauchy's general principle for convergence of a sequence. Idನ್ನು ಯೂಸ್ ಮಾಡಿ ನಾವು ವರ್ಕ್ ಮಾಡ್ತೇವೆ. ಓಕೆ, ನೀವು recall from your memory, you have studied in the last session. ಈ ಸಿಗ್ಮಾ ಯು ಎನ್ ಕನ್ವರ್ಜೆಂಟ್ ಆ್ಯಂಡ್ ಡೈವರ್ಜೆಂಟ್ ಅಂತ ಚೆಕ್ ಮಾಡೋದು ಹೇಗೆ? ಹೌ ಟು ವೆರಿಫೈ ಗಿವನ್ ಇನ್ಫೈನೈಟ್ ಸೀರೀಸ್ ಇಸ್ ಕನ್ವರ್ಜೆಂಟ್ ಆ್ಯಂಡ್ ಡೈವರ್ಜೆಂಟ್. ಕನ್ವರ್ಜೆಂಟ್ ಆರ್ ಡೈವರ್ಜೆಂಟ್ ಟೆಸ್ಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಅಸೋಸಿಯೇಟ್ ವಿತ್ ದ ಗಿವನ್ ಇನ್ಫೈನೈಟ್ ಸೀರೀಸ್ ಎ ಸೀಕ್ವೆನ್ಸ್ ಆಫ್ ಪಾರ್ಷಿಯಲ್ ಸಮ್ಸ್ ಇದೆ. ಓಕೆ, ಇಫ್ ದ ಸೀಕ್ವೆನ್ಸ್ ಆಫ್ ಪಾರ್ಷಿಯಲ್ ಸಮ್ ಕನ್ವರ್ಜಸ್, given series is convergent. Sequence of partial sum is divergent, given series is divergent. ಇದು ಆಸಿಲೇಟಿಂಗ್ ಆದರೆ ಇದು ಕೂಡ ಆಸಿಲೇಟಿಂಗ್ ಆಗ್ತದೆ. ಓಕೆ, ಇಸ್ ಪಾರ್ಷಿಯಲ್ ಸಮ್ ಕನ್ವರ್ಜ್ ಆಗಬೇಕಾದ್ರೆ ಅದರ ಲಿಮಿಟ್ ಫೈನೈಟ್ ಇರಬೇಕು. ಲಿಮಿಟ್ ಶುಡ್ ಬಿ ಫೈನೈಟ್. ಪಾರ್ಷಿಯಲ್ ಸಮ್ ಡೈವರ್ಜೆಂಟ್ ಯಾವಾಗಂದರೆ ಇಟ್ಸ್ ಲಿಮಿಟ್ ಈಸ್ ಇನ್ಫಿನಿಟ್, ಪ್ಲಸ್ ಆರ್ ಮೈನಸ್ ಇನ್ಫಿನಿಟಿ. ಆಸಿಲೇಟಿಂಗ್ ಅಂದರೆ it oscillates between two values, say minus, example minus 1 plus 1 etc. Right? Oscillating between two values. So behavior of an infinite series depends on behavior of the corresponding sequence of partial sums. Therefore, while proving Cauchy's general principle of convergence for a series, You are shifting from here to sequence. Sequence ಅಲ್ಲಿ already it is proved. Already this is proved in the sequence. Now tell me what is the difference of these two. Difference is nothing but modulus un plus 1 up to un plus p less than epsilon for all n greater than or equal to m, p greater than or equal to 1. So we are proving Cauchy's general principle of convergence for series. Fine? Okay. Using this principle, using Cauchy's general principle, using this principle, we will now show that sigma 1 by n is not convergent. It is not convergent or divergent. Sigma 1 by n is divergent. Okay. Divergent. How to show that sigma 1 by n is divergent? Let us make use of Cauchy's general principle of convergence for a series. Okay. Series is mod un plus 1, un plus 2, etc. un plus p. It is less than epsilon for all n greater than or equal to m and p greater than or equal to 1. This condition use ಮಾಡಬೇಕು. Okay. So let us assume the contrary. If possible, let sigma 1 by n be convergent ಅಂತ assume ಮಾಡು. Convergent ಅಂತ assume ಮಾಡಿ. ಇದು convergent ಆದರೆ by Cauchy's general principle ಇದು un ಅಂದರೆ 1 by n, un plus 1 ಅಂದರೆ 1 by n plus 1, un plus 2 1 by n plus 2, etc. un plus p 1 by n plus p. If possible, let sigma 1 by n be convergent. Okay. Then by Cauchy's general principle of convergence, this sum is less than epsilon for all n greater than or equal to m and p greater than or equal to 1. Fine? Okay. Right. So, let us do one thing. For every value of n to the right of m or equal to m, it is true. n greater than or equal to m. p is right of 1. Right of 1 ಅಂದರೆ ಇಲ್ಲಿ ತಗೊಳ್ಬೋದು, ಇಲ್ಲಿ ಕೂಡ p ವ್ಯಾಲ್ಯೂ ತಗೊಳ್ಬೋದು. You can take p equal to m because it is to the right of 1. You can take n equal to m because n is either greater or equal to m. So let us do one thing. In particular, you take n equal to m, p is also equal to m. And epsilon value you choose as 1 by 4. Epsilon value choose it as 1 by 4. Epsilon is 1 by 4 ಅಂತ assume ಮಾಡಿ ನೀವು. ಸೊ ಆಗ ಈ ಸಮ್ ಏನಾಯಿತು, 1 by n plus 1, 1 by n plus 2, etc. 1 by n plus p. ಈ ಸಮ್ ಏನಾಯಿತು ಅಂತ ಚೆಕ್ ಮಾಡುವ. ದಿಸ್ ಸಮ್ ಇಸ್ ಈಕ್ವಲ್ ಟು n equal to m. ಆಗ ಇದು 1 by m plus 1 ಆಯಿತು, ಇದು 1 by m plus 2 ಆಯಿತು, etc. ಇಲ್ಲಿ ಬರುವಾಗ n equal to m, p is also m. So it is 1 by m plus m ಆಯಿತು. m plus m ಅಂದರೆ 2m ಆ್ಯಕ್ಚುಲಿ, ಇದು 2m. ಈಗ ನೋಡಿ ಕ್ಲಿಯರ್ಲಿ. ಓಕೆ, 2m ಉಂಟಲ್ಲ, m plus 1 ಈಸ್ ಲೆಸ್ ದ್ಯಾನ್ m plus m. m plus m ಅಂದರೆ 2m. ಇದರ ರೆಸಿಪ್ರೋಕಲ್ ತಗೊಳ್ಳಿ, 1 by m plus 1. ರೆಸಿಪ್ರೋಕಲ್ ತಗೊಳ್ಳುವಾಗ ಲೆಸ್ ದ್ಯಾನ್ ಇರೋದು ಗ್ರೇಟರ್ ದ್ಯಾನ್ ಆಗುತ್ತೆ, 1 by 2m. ಸೊ 1 by m plus 1 ದಿಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಗ್ರೇಟರ್ ದ್ಯಾನ್ 1 by 2m. ಅದೇ ರೀತಿ 1 by m plus 2 ಇದು ಆಲ್ಸೋ ಗ್ರೇಟರ್ ದ್ಯಾನ್ 1 by 2m ಆಗುತ್ತೆ. ಯಾಕಂದರೆ m plus 2 ಈಸ್ ಲೆಸ್ ದ್ಯಾನ್ m plus m. m plus m ಅಂದರೆ 2m. ಇದರ ರೆಸಿಪ್ರೋಕಲ್ ಇದು 1 by m plus 2 ಲೆಸ್ ದ್ಯಾನ್ ಇರುವುದು ಗ್ರೇಟರ್ ಆಯಿತು, ರೈಟ್. ದಿಸ್ ಆಲ್ಸೋ ಗೋಯಿಂಗ್ ಟು ಬಿ, ದಿಸ್ ವ್ಯಾಲ್ಯೂ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಲೆಸ್ ದ್ಯಾನ್ ದಿಸ್ ವ್ಯಾಲ್ಯೂ 1 by 2m ಪ್ಲಸ್ ಎಕ್ಸೆಟ್ರಾ ಇದು 1 by 2m. ಹೌ ಮೆನಿ ಟೈಮ್ಸ್ ದ ಟರ್ಮ್ಸ್ ಆರ್ ರಿಪೀಟೆಡ್? ಇಲ್ಲಿ 1 ಆಯಿತು, 2 ಆಯಿತು, m ಆಯಿತು. ದೇರ್ ಆರ್ m ಟರ್ಮ್ಸ್, m ಟೈಮ್ಸ್ ಇಟ್ ಇಸ್ ರಿಪೀಟೆಡ್. m ಟೈಮ್ಸ್ ಅಂದರೆ m ಇಂಟು 1 by 2m ಆಯಿತು. m ಇಂಟು 1 by 2m is 1 by 2. So what happens? Your sum is now 1 by n plus 1, 1 by n plus 2 up to 1 by n plus p. This sum happens to be greater than half. It is greater than half. Greater than half is a contradiction to Cauchy's general principle of convergence. If the series happens to be convergent, the sum should be less than epsilon. ಇಲ್ಲಿ epsilon value 1 by 4 ಕೊಟ್ಟದ್ದು, 1 by 2 ಅಂದರೆ ಇಟ್ ಇಸ್ ಗ್ರೇಟರ್ ದೆನ್ 1 by 4. 1 by 2 is greater than 1 by 2. 1 by 2 is greater than 1 by 4. Fine. So this sum happens to be greater than epsilon. Greater than epsilon. It's a contradiction to 1. Contradiction to this one. Okay, contradiction to 1. Why contradiction? Here you have said that the sum is less than epsilon. But ಏನು ಸಿಕ್ಕಿದೆ ಇವಾಗ? The sum is going to be greater than epsilon. It's a contradiction. Why this contradiction? It is due to the wrong assumption that sigma 1 by n is convergent. Therefore this assumption is wrong and sigma 1 by n cannot converge. Sigma 1 by n is divergent. ಇಲ್ಲಿ ನೆನಪು ಮಾಡಿ ನೀವು ಸಿಗ್ಮಾ 1 by n is divergent. ನಾವು ಪ್ರೀವಿಯಸ್ ಎಕ್ಸಾಂಪಲಲ್ಲಿ ನಾವು ಅದನ್ನು ಮೆನ್ಷನ್ ಮಾಡಿದ್ದೇವೆ. ಅಲ್ಲಿ ನಾವು ಸಿಗ್ಮಾ 1 by n power p ಸೀರೀಸ್ ತಗೊಂಡದು. ಸಿಗ್ಮಾ 1 by n power p, it is a p series. This is convergent for p greater than 1. Divergent for p less than or equal to 1. Divergent for p less than or equal to 1. p greater than 1 ಆದರೆ convergent. CGT. p equal to 1 ಆದರೆ divergent. ಇಲ್ಲಿ ನೋಡಿ, ಇಲ್ಲಿ p value is going to be 1. So you are proving that sigma 1 by n is divergent. Here, in this example, by using Cauchy's general principle of convergence. Okay, by using general principle of convergence, you are able to prove that sigma 1 by n is divergent by using different methods. One is Cauchy's general principle of convergence of a series. Another one is p series you can use. And in the later discussion, at the end of the unit, you are going to study a test called an integral test. By using the integral test also, we are able to discuss the convergence or divergence of sigma 1 by n power p. ಬೇರೆ ಬೇರೆ ಮೆಥಡ್ ಉಂಟು. ಕಾಶಿಸ್ ಜನರಲ್ ಪ್ರಿನ್ಸಿಪಲ್ ಯೂಸ್ ಮಾಡಿದರೆ ಈ ರೀತಿ ಬರುತ್ತೆ. ಫೈನ್. ಓಕೆ ನೆಕ್ಸ್ಟ್ ವಿ ಕಂಟಿನ್ಯೂ ವಿತ್ ಸಮ್ elementary results. These results we are going to state only. We are not going to prove it. We are going to only state it. Fine. If sigma un equal to u, sigma c into un is c into u. C can be taken out ಅಂತ ಅರ್ಥ. ಹೀಗೆ ಬರುತ್ತೆ ನೋಡಿ. sigma un equal to u ಅಂದರೆ what is the meaning? Sigma un equal to u ಅಂದರೆ sum of the infinite series is u. Sum of the infinite series is u. What do you mean by sum of the infinite series? With the infinite series, you are associating a sequence of partial sums. You are associating a sequence of partial sum. Suppose the limit of this partial sum, nth partial sum, is finite. Say limit is u anta takolli, u ಅಥವಾ s or whatever you want. If the limit value is finite, say it is u, then the sum of the infinite series is also u. The sum of the infinite series is u. That is nothing but the limit of Sn as n tend to infinity. So when you say that sigma un equal to u, what is sigma c into un anta? C is a constant. C into sigma un ಅಂತ ಬರೀಬಹುದು. ಸಮೇಷನ್ ಸೈನಿನ ಹೊರಗೆ ತಗೊಳ್ಳಿಕ್ಕೆ ಆಗುತ್ತೆ ಇದು. What is sigma un? u. It is c into u. ಇದೆಲ್ಲ ಎಲಿಮೆಂಟರಿ ರಿಸಲ್ಟ್ಸ್ ನೋಡಿ. ಸಿಗ್ಮಾ ಯು ಎನ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಯು ಆದರೆ ಸಿ ಕ್ಯಾನ್ ಬಿ ಟೇಕನ್ ಔಟ್. ಸಿ ಇಂಟು ಸಿಗ್ಮಾ ಯು ಎನ್ ಆಯಿತು. ಸಿಗ್ಮಾ ಯು ಎನ್ ಇಸ್ ಯು, ಸಿ ಇಂಟು ಯು. ಫಾರ್ ಸಿ ಇಸ್ ಎ ಕಾನ್ಸ್ಟೆಂಟ್. ಇಟ್ ಇಸ್ ಇಂಡಿಪೆಂಡೆಂಟ್ ಆಫ್ ಎನ್. ಇಟ್ ಇಸ್ ನಾಟ್ ಡಿಪೆಂಡಿಂಗ್ ಆನ್ ಎನ್. ಇಟ್ ಇಸ್ ಎ ಫ್ರೀ ಕಾನ್ಸ್ಟೆಂಟ್. ಥಿಯರಮ್ 2 ನೋಡಿ. ಸಿಗ್ಮಾ ಯು ಎನ್ ಯು ಆದರೆ ಇಲ್ಲಿ ಒಂದು ಟರ್ಮ್ ಆ್ಯಡ್ ಮಾಡಿದ್ದು. 1ಇಂದ ಸ್ಟಾರ್ಟ್ ಆಗೋದನ್ನು 0ದಿಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ದು. ಓಕೆ, ಇಲ್ಲಿ ಒಂದು ಟರ್ಮ್ ಮೈನಸ್ ಮಾಡಿದ್ದು. ಫ್ರಮ್ ದಿಸ್ ಇನ್ಫೈನೈಟ್ ಸೀರೀಸ್ ಯು ಆರ್ ರಿಮೂವಿಂಗ್ ಒನ್ ಟರ್ಮ್. u1 ಇಸ್ ರಿಮೂವ್ಡ್. ಆಮೇಲೆ 2ಇಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ದು. ಆಗ ಸಮ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ, ದೇರ್ ಇಸ್ ನೋ ಡಿಫಿಕಲ್ಟಿ ವಿತ್ ದಿಸ್, ರೈಟ್? ನೀವು ಇನ್ಫೈನೈಟ್ ಸೀರೀಸಲ್ಲಿ ಯು ಆರ್ ಆ್ಯಡಿಂಗ್ ಎ ಟರ್ಮ್ ಆರ್ ರಿಮೂವಿಂಗ್ ಎ ಟರ್ಮ್. ದೇರ್ ಇಸ್ ಬಿಹೇವಿಯರ್ ಚೇಂಜ್ ಆಗಲ್ಲ. ಕನ್ವರ್ಜೆನ್ಸ್ ಇದ್ದರೆ ಕನ್ವರ್ಜೆಂಟೇ ಇರುತ್ತೆ, ಡೈವರ್ಜೆನ್ಸ್ ಆದರೆ ಡೈವರ್ಜೆಂಟೇ ಇರುತ್ತೆ. ಥಿಯರಮ್ 3 ನೋಡಿ, ಇಟ್ ಈಸ್ sum of the first series is u, sum of second series is v. Then what is the sum of that is u plus or minus v, sum of the two. How do you add the series? You are adding sigma un and sigma vn term wise. un plus or minus vn, u1 v1, u2 v2, u3 v3, term wise you are adding. You can add two infinite series term wise. Fine. Convergent series may be added or subtracted term by term. That's what theorem 3 says. ಇದೆಲ್ಲ ಎಲಿಮೆಂಟರಿ ರಿಸಲ್ಟ್ಸ್. ಜಸ್ಟ್ ಇದನ್ನು ಸ್ಟಡಿ ಮಾಡಿ ಇಲ್ಲಿ ಏನು ಹೇಳಿದ್ದಾರೆ, ವಾಟ್ ಈಸ್ ಬೀಯಿಂಗ್ ಸೆಡ್ ಹಿಯರ್, ಪ್ಲೀಸ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದಟ್ ಈಸ್ ಸಫಿಷಿಯಂಟ್. ಓಕೆ, ಇಲ್ಲಿ ನೋಡಿ ಥಿಯರಮ್ 4 ಅಲ್ಲಿ ಸೀರೀಸ್ ಸಿಗ್ಮಾ ಯು ಎನ್ ಕನ್ವರ್ಜಸ್ ಟು ದ ಸಮ್ ಯು, ದೆನ್ ಸೋ ಡಸ್ ಎನಿ ಸೀರೀಸ್ obtained by ಫ್ರಮ್ ಸಿಗ್ಮಾ ಯು ಎನ್ ಬೈ ಗ್ರೂಪಿಂಗ್ ದ ಟರ್ಮ್ಸ್ ಅಂತ. ಗ್ರೂಪಿಂಗ್ ಅಂದರೆ ನೀವು ಫಸ್ಟ್ ಟರ್ಮ್ ಸೆಕೆಂಡ್ ಟರ್ಮ್ ಒಂದು ಗ್ರೂಪ್ ಮಾಡಿ, ಥರ್ಡ್ ಆ್ಯಂಡ್ ಫೋರ್ತ್ ಒಂದು ಗ್ರೂಪ್ ಮಾಡಿ, ಅಥವಾ ಫಸ್ಟ್ ಟರ್ಮನ್ನು ಬಿಡಿ, U1 ಬಿಡಿ, U2 U3 ಗ್ರೂಪ್ ಮಾಡಿ, U3 U4 ಗ್ರೂಪ್ ಮಾಡಿ, ಗ್ರೂಪ್ ಲೈಕ್ ದಿಸ್. ದ ಸೀರೀಸ್ obtained by grouping the terms in brackets without altering the order. Right? If you group the terms without altering the order, ಟರ್ಮ್ಸನ್ನು ನೀವು ಗ್ರೂಪ್ ಮಾಡಿದರೆ, ರೈಟ್, ದ ಬಿಹೇವಿಯರ್ ಆಫ್ ದ ಸೀರೀಸ್ ವಿಲ್ ನಾಟ್ ಚೇಂಜ್. ಸಿಗ್ಮಾ ಯು ಎನ್ ಬಿಹೇವಿಯರ್, ಇದು ಕನ್ವರ್ಜೆಂಟ್ ಆದರೆ ಇದು ಕೂಡ ಕನ್ವರ್ಜೆಂಟ್ ಇರುತ್ತೆ, ಇದು ಡೈವರ್ಜೆಂಟ್ ಆದರೆ ಇದು ಕೂಡ ಡೈವರ್ಜೆಂಟ್ ಇರ್ತದೆ. ಆನ್ ಗ್ರೂಪಿಂಗ್ ದ ಟರ್ಮ್ಸ್ ಇನ್ ಬ್ರ್ಯಾಕೆಟ್ಸ್ ವಿದೌಟ್ ಆಲ್ಟರಿಂಗ್ ದ ಆರ್ಡರ್ ಆಫ್ ದ ಟರ್ಮ್ಸ್, ರೈಟ್, ದ ಸೀರೀಸ್, ದ ಬಿಹೇವಿಯರ್ ಆಫ್ ದ ಸೀರೀಸ್ ರಿಮೇನ್ಸ್ ಸೇಮ್. If the series sigma un converges to the sum u, then so does ಅಂದರೆ after grouping the terms by using brackets, then also the behavior is going to be same. ಇಲ್ಲಿ ಕನ್ವರ್ಜೆಂಟ್ ಆದರೆ ಇದು ಕೂಡ ಕನ್ವರ್ಜೆಂಟೇ ಇರುತ್ತೆ. ಇಟ್ ಇಸ್ ಆಲ್ಸೋ ಕನ್ವರ್ಜಿಂಗ್ ಟು ದ ಸಮ್ ಯು. ಸೊ ಇದನ್ನೆಲ್ಲ ಕನ್ಸಾಲಿಡೇಟ್ ಮಾಡಿ ಒಂದು ಸಿಂಗಲ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಕೊಡೋದಾದರೆ, ಐ ಕ್ಯಾನ್ ಪುಟ್ ಇಟ್ ಲೈಕ್ ದಿಸ್: ದ ಬಿಹೇವಿಯರ್ ಆಫ್ ಅನ್ ಇನ್ಫೈನೈಟ್ ಸೀರೀಸ್ ಇಸ್ ನಾಟ್ ಆಲ್ಟರ್ಡ್ by adding a finite number of terms, or by omitting a finite number of terms, or by altering finite number of terms. The behavior of an infinite series is unaltered by the addition, omission and deletion, alteration, right? Addition, deletion, ಅಥವಾ addition, omission or alteration ಅಂದರೆ modify few terms, right? The behavior of the series is not altered. Okay, behavior of an infinite series is unaltered by the addition, omission or alteration. Adding few terms here, ಒಂದು ಇನ್ಫೈನೈಟ್ ಸೀರೀಸಿಗೆ ಒಂದು 10 ಟರ್ಮ್ ಆ್ಯಡ್ ಮಾಡಿ, ನೀವು ಆ್ಯಡ್ another 10 ಟರ್ಮ್ಸ್ ಒಂದು ಇನ್ಫೈನೈಟ್ ಸೀರೀಸ್ಗೆ ಆ್ಯಡ್ ಮಾಡುವಾಗ ಒರಿಜಿನಲ್ ಸೀರೀಸ್ ಕನ್ವರ್ಜೆಂಟ್ ಆದರೆ after adding 10 terms also it is convergent. You remove 10 terms, 10 term ತೆಗೀರಿ ಬೇಕಾದರೆ, few terms you remove, then also behavior does not change. Alter, ಕೆಲವು ಟರ್ಮನ್ನು ಮಾಡಿಫೈ ಮಾಡಿ, 1/2 ಇರುವಲ್ಲಿ 1 ಅಂತ ಹಾಕಿ ನೀವು, ಅಥವಾ 1/3 ಇರುವೆಲ್ಲ 1/2 ಹಾಕಿ. ಸೊ ಬೈ ದ ಅಡಿಷನ್ ಆಫ್ ಫ್ಯೂ ಟರ್ಮ್ಸ್, ಒಮಿಷನ್ ಅಂದರೆ ಬಿಟ್ಬಿಡೋದು, ಎ ಫ್ಯೂ ಟರ್ಮ್ಸ್ ಯು ಡ್ರಾಪ್ ಆರ್ another few terms you alter. By the addition, omission or alteration of finite number of terms of the series, behavior of a series does not change. Behavior of the infinite series is not altered, it is unaltered. Fine? Okay. So with this we take a break here. Positive term series we keep for the next class. Positive term series, let it be for the next class. Right? You study little by little. Right, by the end of the month we are completing the unit. By 30th of August, at least by 29th, 30th of August we are trying to finish the unit. So you study little by little, right, to make yourself very confident in the topic. Thank you.